I am Stephen O'Grady. I'm the principal analyst and co-founder of RedMonk. Some of you may have seen me talk here today. So that's my introduction. I'm going to ask the panelists to introduce themselves briefly. So I'll kick it over to Grant.
Sure. My name is Grant Ingersoll. I'm a longtime Lucene and Solar committer and contributor, and also one of the co-founders of Lucid Imagination, as well as Apache Mahout.
I'm Graham Tackley. I'm platform team lead at Guardian.co.uk, so I both deliver new features like the Content API, and it's my job to keep the website up and running.
I'm Josh Burkus. I'm on the PostgreSQL core team for the PostgreSQL database. I'm also president of a consulting company, PostgreSQL Experts, Inc.
So Grant, we'll start with you. Obviously we're here to talk about search. We're here to talk about Solar and Lucene, among other things. So what has changed in the work that you've done with customers, and certainly what you guys see at Lucid Imagination? What has changed about perceptions of open source search in the last 12 months?
That's a good question. I mean, I think for a long time, just with open source in general, of course, people were, hesitant or, concerned. What is the legal ramifications of using open source, as well as is it good enough technically? I think, with sites like Twitter and very large sites openly publishing and talking about their use of Lucene and Solar, that really there's that confidence level that people have, both at the engineering level as well as at the business level, that this is something that's good to use and is going to give a lot of benefits for the company. So I think you're really seeing a lot of continued adoption. And then of course, technically speaking, I think in probably the last year there's been as much, if not more, innovation in Lucene and Solar than probably in many of the previous years before that combined. So it's really quite an exciting time for people to be involved in consuming it.
Okay. And Graham, on the emails that we exchanged beforehand, you expressed a very well, you have strong opinions, let's put it that way, on the relational database and certainly its role within the Guardian and certainly relative to the role of search. So can you talk about sort of where you've come from with relational databases and where you are now at the Guardian?
Yeah, so our main website is still run off a big Oracle database, but I've pretty well wasted 3 years of my life putting layers and layers of complexity on top of that database in order largely to make it eventually consistent, and in order to make it perform so that we can still continue to deliver all of the functionality we want to deliver on our website. So lots and lots of stuff that's not to do with what we actually want to do, but putting layers of caching into Hibernate, putting memcached in, and all sorts of stuff to try and work around the fact that actually the relational database wasn't the right tool for us. And then more recently, we've introduced our Content API. That is entirely backed by Solar. And it's wonderful because I don't care about how many people can hit it, how many people are hitting it, because if it starts getting busy, I just kick up a couple more servers in the cloud, and they replicate, they're up and running, and it's great. So our conclusion from all of this experience is that actually we're never going to use a relational database for a future project again. So our future strategy is a combination of Solar and Mongo.
Okay, excellent. So the logical next question is to turn to Josh. So Josh, as he mentioned, is a committer to the Postgres project, among other responsibilities, a very well-regarded open source relational database. So Josh, you've been working with clients around Postgres obviously for a long time. And certainly we've seen a lot of those clients adopt a variety of tools. When you work with your clients, how do you talk to them about when to use a relational database and when to use other tools, search included?
It's really a question of what does your data look like and what do you want to do with it? Because if what you have is a bunch of financial transactions or a bunch of taxonomy information and statistics that you want to run summaries and reports on, then a relational database is probably the right answer for you. That's something that relational databases do extremely well. They do better than any other kind of database. On the other hand, if what you have is a whole bunch of basically documents or a whole bunch of web pages and that sort of thing that you don't actually necessarily know what's in them, that you don't necessarily even want to know what's in them, you want the user to find that out, then one of the first things I would end up talking to people about would be, say, Elasticsearch or Solar, which is going to be a lot better for that. The difficult cases are the borderline cases. The difficult cases are the ones where you have a little of both. And I can't give you sort of a uniform rule that will tell you, hey, I'm going to be doing some search, but I'm going to be doing a lot of transactions here, and I need to do a lot of roll-ups or a lot of sort of, per customer views and that sort of thing. And I don't actually have a good answer for which tool exactly. I would tend to use a relational database in that case just because I'm a lot more familiar with the technology and I know how to work around the problems. But if I was Graham or Grant, I would probably use Solar and add a bunch of stuff on top of it in order to make that work.
Coming out of that, is sort of questions of data and data structure. And certainly one of the things I talked about this morning was unstructured data. And again, I know that at least two of the panelists have very strong opinions on what constitutes unstructured data and what does not. So a question to all three of you. When you look at data and what's appropriate for, say, a relational database versus search, how do you define structure? How do you define, what is sufficiently structured and what is not? Is there such a thing as unstructured data, period? And I guess we'll start with Grant.
Yeah, I'm actually of the mindset that there's no such thing as unstructured data because, even obviously human language has structure to it. We have sentences, paragraphs, words. You can't just put words in random order. It's just that we don't quite have the tools to properly process all of that. So this is kind of the area of natural language processing. So, what natural language processing tends to do is take and try to learn some type of structure that's in the text itself. So traditionally unstructured would mean free text or something like that. But if you look at most of the techniques around natural language processing, they're trying to extract information and provide some structured overlays onto that text so then you can use more traditional approaches like what you're used to doing with relational sets and things like that. So I think you have to choose the right tool as well for the situation.
Okay.
Basically, the way that I summarize it is there's two kinds of data. There's data whose structure you know in advance, and there's data whose structure you don't know in advance before receiving the data. And when people talk about unstructured data, they're generally really just talking about data whose structure they don't know in advance, whose structure they need to discover.
That leaves me on the panel who didn't have an opinion about structured or unstructured data. I think the interesting thing from our perspective is that actually we do know some of the structure of things we're working with when we start, but as we go on and as we evolve and add new functionality, our view and understanding of how we want to structure things changes. And so one of the things that's really held us back on a relational platform is the difficulty in evolving the structure to match our improved understanding of what we're actually interested in the things that we're dealing with. Okay.
So a quick question, and this is a yes or no for the panelists. Do you see today, a more heterogeneous data environment than you did 5 or 10 years ago?
Yes.
Okay. Graham?
Yes.
Josh?
Unquestionably.
Okay. So that actually was the answer that I was hoping for. Given that reality, given that we have a more heterogeneous data infrastructure these days, we're using more tools, tools aimed at sort of different data types and different workloads. What are the problems that you guys see in terms of making them all work together? Right? When you have obviously different tools, when you have essentially different data workloads that you're processing, search, relational databases, key value stores, Hadoop, all the different things that that the audience has been hearing about since I got here. What are the challenges that you guys have, the primary challenges that you guys have in terms of making them work together? And we'll start at the other end this time with Josh.
Well, integration is a big problem, and it's something that our company, my consulting company actually does a lot for customers, is actually doing integration. How can I take this Postgres transactional data and put it into a Redis queue only when it commits? How can I take this data that's actually being uploaded into Postgres and then index it in Solar? How can I take this data that's actually being updated in Solar and then put the metadata into Postgres? And that's actually going to be a huge thing. And I think right now people are using special tools for very specific purposes and struggling a lot with integration. And I think 5 years from now, that's actually going to drive people towards using tools that agglomerate more and more functionality from other tools.
Okay. Graham or Grant?
Yeah, so Josh, I think you're right. The market to be in right now is the thing that takes data from one thing and puts it into another, because that's we now spend a lot of our time doing that kind of stuff, and I'm sure many other people do as well. I'm actually, that sounds painful, but I'm actually really pleased about that, because I've used the half-baked attempts by people in one particular sphere to do something else. So I've had the joy of using Oracle free text search and SQL Server's free text search, and coming to Solar, actually you've got a tool that does one job and does it fantastically, well, at least one job, but does it fantastically well. So I'd much rather have the pain of integration than try and have one tool that does every job kind of okay.
Yeah, and if I might add, I mean, I think the thing that you're seeing is actually a good thing too, because for a long time it was, you know, it's the old hammer saw that everybody says, right, is, you know, I'm going to use this hammer for everything. So people are finally realizing that a database isn't necessarily the only thing I should be using, but they should try out these other things and use them more effectively. I mean, I think what we see is, you know, people just have a hard time with, they want to make sure, you know, things like update rates of the data and availability and all of that stuff is where people probably struggle at the technical level in terms of integrating all of the different pieces. But it really also gets at how do you want to make that data available to people, and therefore it's, you know, which tool is the right job for making that that data available.
Okay. So the next question to the panelists, while you guys think of questions that you might want to pose, concerns open source, as I mentioned. So the one thing that all of you have in common, at least I believe that you have in common, is that you all are invested to some extent in open source, you know, either, you know, as a vendor, as a consultant, or certainly as a user. So clearly it's a technology, or it's an approach, I should say, that you guys believe in, you know, to, you know, presumably varying extents. You know, what can you tell us about the way that your customers or your organization views open source? And to just provide some context, you know, open source obviously has made inroads in a lot of areas of the enterprise, you know, over the last 10 or 20 years. The database, however, you know, has been kind of one of the last holdouts. It's been one of the hardest, you know, to penetrate to a certain extent, because a lot of people still believe, well, all right, I'll use an open source operating system, I'll use an open source application server, or web server, and so on. But, you know, I still rely on, you know, Oracle. I still rely on these closed source products. So what can you tell us about where we are today in terms of, you know, how, as I said, your customers or your organization views open source, you know, in the context of data and how you manage and process data? So we'll start with Grant.
Well, I think that one of the biggest things is, you know, as we've seen just this absolute explosion in data, that the proprietary engines, for instance, just become so costly that you simply can't afford to scale them, even though they may be able to technically scale. They just, you can't afford the licenses unless you're, you know, a super large company. So if you're a startup or even a mid-sized company, being able to afford it, you just end up doing open source and then making using the open source, and then you all of a sudden it's like the light bulb goes off because you realize, hey, this stuff is really good. So in fact, like with Lucene and Solar, I think, you know, one of the things I see routinely is that it's by far and away the most widely adopted search library on the planet. I think even taking on almost all of the commercial vendors, if you look at all of the places that Lucene is embedded in, it just ends up being so widely adopted. It's just most people don't know it actually is inside there because it just works.
Okay. Agree.
Yeah, we're absolutely passionate about open source. We love using it. We love committing back. We love trying to spin out the stuff that we're working on as open source as well. And one of the things that I find absolutely fascinating is repeatedly, when we've been comparing commercial products to open source products, actually the open source product wins, even disregarding the concept of license fees, even disregarding the cost of licensing. We find the open source development model ends up with something that isn't meeting a set of marketing guys' featured list. It's ending up meeting the requirements of people who are actually using it. So we use Postgres in one place, which was our first move away from Oracle, and it's a lot better because it's designed for people who are actually using it. So we love open source, and we think it's much better much closer, much more likely to deliver what we need.
Okay, Josh?
I would say, so first of all, I'm going to disagree with you in terms of last holdout. I would say the last holdout for closed source is vertical industry applications.
Okay, that's fair.
And actually, I've seen a real change in databases over about the last 4 years in that I no longer have to justify the open source portion of the database picture.
Okay.
Now, customers, even like talking to large companies, their questions are actually about specific features. Does it support X? Does it support Y? Can I do this? They're not really, the fact that it's open source is no longer a concern for the majority, actually, I would say, of companies out there. If anything, it's regarded as an asset, and occasionally it's regarded as irrelevant.
If I might add too on the last one while we wait is, I think one of the things that's really interesting is you're starting to see that actually the real innovation is happening in open source as well, as new features are coming into the open source before any vendors have them as well. Whereas before it used to kind of be open source was copying somebody else, whereas now I think it's kind of the other way around.
Yeah, I think that's fair. One of the questions that I got in my session this morning, concerned essentially visualization, analytics, infographics, those kinds of things, about trying to make sense of data. And that, as far as I'm concerned, is kind of a fairly significant, still unsolved problem. We have some useful tools, but we're certainly not there yet, right? We have very good underlying infrastructure, but that's, as far as I'm concerned, still a kind of work in progress. At The Guardian, you guys obviously do really, really interesting work about taking lots of different types of data and trying to make it accessible to essentially a mainstream audience, if you will, an audience which really doesn't concern itself with data. So from your perspective, in that process, is it, do you think it's visualization analytics, or is there some other big area that you think is kind of just a, hey, look, yes, we've made progress over here, but we still have a long way to go over there?
Yeah, so I think we've started to make some progress on there. So it's really exciting being involved in some of the data journalism that we do. So my favourite example of that is we did some analysis of UK government spending and came up with a big chart of where the government spends their money. And a guy from the Treasury phoned us up and said, could they have it please, because it's the best representation they'd seen, which is awesome. As a journalistic organisation, that is a fantastic confirmation. Right now, most of the analysis we're doing like that is in Excel and powerful tools like that, with a bit of Solar if it's something we need to do. I think there's going to be huge growth in doing things like that. There's still masses of data out there, lots of information available that I think we can do a lot better job of analysing, and I don't think we've even started properly yet.
Okay. So to Josh and Graham, same question essentially, but in the context of Graham's remarks, what do you see as the big hole? What do you see as kind of the remaining obstacle in terms of hey, users can do X, Y, and Z, but they can't do not X, Y, and Z?
I'll give you one that I'm struggling with right now, actually, which is the whole concept of data versioning. That is, of having different versions of data, some of which may be a matter of opinion, because I do a fair amount of work with open government data. And one of the issues that we're struggling with this with, like, on the Sunlight Foundation and with some of the projects, now in terms of companies opening up data, is you have a lot of both proprietary data and proprietary formulas in particular, whose whole sort of thinking may be dubious, and people want to actually be able to say, okay, well, if I wanted to manipulate it this way, what would it look like? And and Josh thinks that the formula should actually be this, and therefore the entire visualization should look like this instead. And I'm discovering that we don't actually have good tools to do that right now. That we're looking at writing a lot of ad hoc code that will be incredibly CPU intensive. And I think that's actually going to be a big sort of portion of the future of where we need to go with data is that the data needs to be not only, you know, accessible, but it needs to be versionable.
Okay. And Grant.
Yeah, actually, I think there's a couple of levels here. First off, on the data level, I think one of the cool things that's happening is people are finally making this data available that we can all share. Because I know in open source, when you're working on an open source project like you know, either a database or search, you want to be able to test at scale. And in order to be able to test at scale, you need to have a lot of data that you can test with. So it's nice that there's all of these open data data sets, things like what InfoChimps and others are doing to make data available, or you can go grab the open government data. I think another area, and this is one that I'm seeing more and more, is, you know, having worked a lot with Mahout, is this. What you're seeing out of a lot of the kind of leading edge companies, you know, the Googles, the Facebooks, et cetera, is they're starting to use very effectively things like machine learning as part of all of the various things that you're doing. So one of the, you know, like Mahout project is all about bringing scalable machine learning to the masses. So this, I think, is going to help plug some of these holes around analytics that people have. Just like they have for Lucene, they have tools for doing machine learning very effectively. And then I think the last thing on, you know, your ad hoc querying kind of thing, what you're seeing in the business intelligence areas, more and more of that being driven by search underneath, so that people can do ad hoc search queries and then have this layer of business intelligence on top of the results that you get back from your searches. So that can help some with the ad hoc nature of the way different users want to interact with the data, but then see visualizations.
Okay. Any questions from the audience? The question is, what is data versioning, essentially? Go ahead.
So say, for example, I have a bunch of Treasury data, right? And so I've got a bunch of raw Treasury data, and the Guardian has done this terrific visualization of how that breaks down. But say I don't agree with the categories the Guardian is using, and I want to apply my own set of categories to that. And not only do I want to apply my own set of categories and see the visualization based on my set of categories, but then I actually want to somehow upload my own set of categories, you know, with my comments and timestamp, and have other people be able to use that and build on it.
The next question kind of stems from something I touched on a little bit this morning. You know, when we talk about data, you know, certainly as analysts, you know, one of the things that, you know, we see continually, and, you know, probably many of you in the room have seen the same thing, is that, you know, really the term or the trend that is garnering the most attention at this point is quote unquote big data. So, you know, the question, you know, to the panelists, you know, is, you know, what do you think the bigger challenge is from your individual perspectives? Is it the size and the scale of the data, or is it the, you know, the structure and the nature of the data itself? What is the bigger challenge for you? And we'll start with Grant. Or, I'm sorry, we'll start with Grant.
Grant or Graham?
Grant. We'll start at this end. Go
Or
ahead.
is it the hype around it?
Yeah, well, it could very well be the hype too.
So I'm sorry. So it's
it's complexity versus data size and volume.
Yeah, well, I mean, I think one of the things I often run into is, first off, everybody thinks they have a lot of big data, but many of them actually don't. So, you know, one person's big data is another person's small data.
Right.
So, you know, I mean, I think it probably depends on the kind of data as to whether the complexity of it is. But you know, the scale size, you know, I think very few people actually generate the kinds of big data that people are always designing systems for. So I think sometimes there's this sexiness around, oh, I'm going to do big data and all of this stuff, but it's often overkill for what you're actually doing. So again, it's just almost like before, you know, where the database was always the hammer. It's like, make appropriate choices as a technologist. This is your job to decide what are the appropriate tools that I need, as well as how big do I really think I need to make this. You know, do I need to design a system that's going to handle 500 petabytes when I've only, you know, I'm not going to see that for 10 years if everything in the world aligns for me in the meantime.
Right.
The big problem is, and I'll define big data, is big is in relation to your resources. So,
okay.
You know, the thing is, if I'm Facebook, then managing petabytes is more or less what I do. Yeah. If, on the other hand, if I'm a San Francisco nonprofit, then having a terabyte of data can actually be a big struggle, because I only have enough money for one server, right? But if your data is big in comparison to your resources, the most difficult part is it ties your hands in terms of the decisions that you make. That is, if you decide that you want to deal with the data in a certain way, I want to stick it all in a Lucene instance, I want to stick it all in a relational database, I want to structure the data in a certain way, I want to have this hierarchy, then changing those decisions becomes extremely painful. Making a change to that decision can involve hours or days of downtime, or the alternative of laying out for a lot of duplicate hardware in order to support the change. And that's actually what becomes difficult when your data is big in comparison to your resources, is that you actually have to make those decisions a lot further in advance than somebody whose data is fairly limited in scope.
Okay.
I think Grant's comment was very interesting, because one of the things we did was one of us came back from a conference and we thought, Hadoop thing's really cool. So what we did was loaded up a month's worth of our clickstream data into Hadoop. It was awesome. We did all sorts of, we loaded it up. It was great. We could answer all these, we could run all these queries on it. And then we kind of said, well, actually, what do we want to know? And so we could do all of that stuff with big data, but it didn't resolve us and absolve us from the original problem, which was actually, what's the question I'm trying to find out by processing this data? What do I actually want to know? And so actually we haven't done it since as a result.
Yeah. I would actually add to that the growth of hardware systems capacity in every way has actually made that problem a lot worse, which is that a lot of companies, their tendency is to say, okay, well, I'll store it now and I'll figure out the questions later.
Right.
But it doesn't actually help them figure out the questions.
It makes it harder, indeed.
It just occurred to me that it's been mentioned several times the problem is with big data not necessarily being able to answer the question, but actually knowing what question to ask. Is anyone actually looking at that whole? How can technology help us find out which questions we want to ask when presented with a large amount of data?
Great question.
Yeah, I mean, I think that's somewhat what Manhattan machine learning is trying to do. Is you can do unsupervised learning kind of things and essentially crunch through a lot of pieces of data and have it try to discover patterns in it for you, and then present that to the humans so that they can then decide where and how they want to drill down into it. So techniques like clustering and classification and stuff like that can help you deal with all of this content that you haven't seen before, but as well as look at your things like your transaction logs and see, for instance, in like a search context, people who search for these items are also searching for those items based on what kind of transactions they're doing. As well as, essentially like collaborative filtering, those kind of recommendation systems where what are other people doing in relation to this content, so that you can then maybe have some more insight into these are the trends that you're seeing on your site or in your application.
I think very often, actually, it's potentially a distraction to try and look for technology to help you ask what questions you want to have answered. I think very often, actually, why are you doing this in the first place? What's the business problem you're trying to solve? So I'm quite slightly nervous of saying, actually, there's a technology solution to this. In fact, there's a business decision-making process to deal with that.
The only thing I can see technology actually doing in that respect is when you come up with your first questions, allowing you to answer them faster. Which does allow you to refine the questions once you've come up with the initial questions. Once you've said, is this actually an interesting question to ask? Is this actually a question I can ask? The fact that you can get the answers so much faster now should be helping us ask better questions. In practice, I find that it's not. In practice, I find is somebody asking, because this is one of the things we do for clients. Somebody asks me to get the answer to a question out of the database, and I get them the answer in less than an hour, and they weren't expecting that. And I'm sure you get this even more in search.
Right.
They weren't expecting that, and then you don't hear from them for 3 months while they try to figure out what the next question is.
Well, the only thing I would add is that I think if the folks in the audience have seen Google Correlate, I mentioned it this morning, Google Correlate I think is an interesting indication of where things can go, because that will identify patterns for you that you might not identify on your own. In other words, if you go to Google Correlate right now and you do a query for Hadoop, the top correlated result, according to Google Search Index, is Oracle 11G, which I wouldn't necessarily make that connection myself. So I think that there are hints of, kind of where some of that is going. Other questions?
In relation to that question, the question of what exactly to start, I think there's the data relation database and there's Lucene, which index data. Lucene does the job pretty awesome, we all know. The question is that the data nowadays, I run some processing and find out what data to store, but data is very valuable. No matter what, the data that I might think, oh, that's not valuable now, it might be very important tomorrow. And the question is more exactly how to, if you see in the near future, a more integration in our relational database, pretty much admitting that they're not, they all know about indexing, but having the ability to allow third-party indexing as well, and then work together as a native integration. How do you see that in the future?
How do we see that playing out? Is that the question?
Yeah, how does that play around, like the relational database vendors right now? Do you see them allowing third parties indexing, such as Lucene, to be used native?
Well, we have a relational database kind of panel. What do you think, Josh?
Well, I can't speak for all relational database vendors, but I can tell you that one of the biggest features of our upcoming version is something called SQL Med, which is designed to allow you to do things like query Lucene from inside Postgres. It's a way to allow you to actually run SQL queries in the Postgres database and have them query foreign data sources, which can be anything. Specifically because you recognize that Lucene's going to be better at searching text and similar things than we are going to be internally at Postgres. There's a lot to be done in terms of integrating that also from a writing standpoint, but we're certainly doing that. And I know for that matter, well, actually, I can't speak for one other relational database vendor. One of the big things that they're doing in the MySQL world is actually integrating Sphinx, which is your sort of alternative for this. I'll say from the relational database side, if you look at the history of relational databases, actually for the last 10, 15 years, relational databases have added functionality that came from elsewhere. We got XML databases, and then what happened? Every relational database added an XML support. So I think that's going to continue on the relational database side.
Yeah, actually on the search side, I mean, you've seen things like some transactional semantics being added to Lucene and things like that. Also, I mean, I'm aware of, I think there's directory implementations in Lucene, so this is a low-level thing for Oracle as well as some of the other vendors. So, and that's been going on for a while. So I think there is always this kind of continuous need that we need. You need to have them work together as seamlessly as possible. So as the technologies improve, the databases are coming more like search-like, and the search is becoming more database-like. And you need both to solve the various problems.
Yeah, I agree. So I think that integration is definitely happening. I think we're not prepared to wait for that, so what we're tending to do is put APIs in front of our data stores so that all of our application layers are talking to the API, and then they will, and we're anticipating for the foreseeable future, a mixture of data stores at the back end that we'll update as a result of calling that API, and we see those changing round over the next few years extensively as some other new data technology comes along.
That's great. The question I wanted to ask, specifically Josh and Grant, but I'd be interested for a little bit of a different perspective from Graham. One of the questions that we get pretty frequently on open source concerns contributions and concerns where the contributions from, to a given project come from. And more particularly, the work that you do with individual clients, if they are, altering code, if they're making changes, if they're making updates, do they, have the ability to get some of these changes back upstream? So, to the extent that you're able to comment on it, and we'll start with Josh, when you are doing work for clients, or when clients are doing work themselves, is that code coming back upstream?
That's actually something we do for clients some of the time.
Okay.
I mean, in general, most of the clients that we work with, and it's going to end up being a fairly self-selecting group, but most of the clients that we work with understand the value of not effectively maintaining a fork themselves.
Right.
Because there's no real benefit to it for a company that's a user, and there's a lot of cost. So one of the things that we'll end up doing for clients, depending on the circumstances, either paid, sometimes paid, more often on our own time, is taking the changes that we've made for clients or the changes that we made with client staff efforts and actually pushing those into the upstream projects. And that's actually, at this point, for our companies involved, contributions to Postgres, contributions to Django, contributions to Redis, for different clients who needed improvements in those areas.
Okay, and Grant?
Yeah, actually, I mean, if the contribution is core to Lucene or Solar, we won't take on the work unless it is allowed to be contributed back, because we don't want to be in the situation of having done this work that we think is valuable and it was done as work for hire, and then there's all these legal entanglements, and then if somebody else comes along later and does something similar, and we would kind of be in this stuck in the middle of legally being not allowed to contribute or work on it. So we tend not to, if it's core into Lucene or Solar, we say if we're going to do that work, we'll do it through patches in the open source, and it's all part of the community process. We also don't, the commit process, that's all still done by us as individuals outside of what we would do for our clients. We just basically put up patches, iterate there, and then and tell the client that we think this patch is ready, and then from there on out, it's up to the community as to whether it's contributed or committed. So
okay, and Graham.
Yeah, I think one of the really good things about working for an organisation where the editor goes on and on about open journalism is it's quite easy for us then to say, okay, yes, we want to do open source work and open up what we're doing. So we have a policy that when we fix something, when we look at something, we try and push that change back. Now, we haven't done anything on Solar because for us, Solar has just worked, but we've got lots of commits on various bits of Scala technology that we're using. So, yeah, we push back.
Great. A question right here.
Sure. My question is, I guess to date, search has been sort of meaning agnostic. Search technologies don't try to identify what certain concepts actually mean and how they relate to one another. This seems to be something that there are a number of sort of vendors working on. Sort of, I guess you could describe it as semantic search, dealing with ontologies. How do you see sort of what do you think the impact of semantic search is in search in general and specifically open source search?
I guess that one's at me, Josh, unless you want to take that.
Right, I have no opinion about semantic search.
There you go, that's easy.
I don't know that I have much of a strong opinion. I would say, though, that actually, I mean, if you look at things like latent semantic indexing or analysis, I mean, that's been around for quite some time and has, the idea behind it is that it's doing conceptual level searching. Back in the 90s when I first started on search, the very first project I did was a conceptual-based search engine. The results were okay. It was a cross-language conceptual search engine, so you map each language, you map to a concept, and then you did the search on the conceptual level, but you often had to supplement it with the actual keywords. So, it's been a very evolving area. I mean, I think there's some exciting things that are happening with it. I think I saw the other day, and I haven't tried it out yet, but the Siren work that does essentially is indexing triple stores into Lucene, as well as, I mean, obviously, as we get better and have more data to build out these statistical models around language, and you start applying these tools like natural language processing into the mix, you can really use those to help drive better search by getting at what the actual content is that you're searching against. That being said, on the user side, if you're only putting in one or two keywords into the search box, how much conceptual information can you actually get from that? I don't know. I think that remains to be seen.
So to pick up on one of the questions we heard earlier, and actually, Josh, you touched on this as well, the question of querying time, right? So the idea that, the quicker you come back with a query, and certainly the more accurate the query is, obviously the more likely they are to continue to iterate and try to ask different questions. So, what are the kinds of things that you can do, or certainly the folks in the audience can do to optimize for that? Whether we're talking on the relational database side, or the search engine side, how do you, from a process standpoint, an approach standpoint, make sure that you deliver the right answer, as quickly and efficiently as possible, just in broad strokes?
One of the things that relational database that's sort of built into the relational database architecture is delivering the right answer, just not necessarily quickly.
Right.
So that's been the sort of relational database trade-off for a long time. So the delivering the right answer portion of things is pretty effortless, limited by the garbage in, garbage out problem. Delivering the answer quickly, there's a whole body of knowledge about tuning relational databases and that sort of thing. I mean, the biggest thing actually is, since the whole concept of a relational database is that you know something structurally in advance about the data that you're actually going to be the data you're actually going to be looking at, is that structure should, particularly when it comes to things like indexing and that sort of thing, be related to the questions that you're expecting to ask, or that you should be ready to change the structure when the questions change. A lot of people actually get into this idea often because they work in a company that has a DBA department that's completely separate from the developer department or completely separate from the analytics department, whose main job skill seems to be saying no. That once the relational database is built, you can't change the structure, which then makes you wonder why the SQL standard has 100 pages of syntax for data structure change commands. That was exactly the opposite of the whole idea of relational databases in the first place.
Right.
So I mean, I guess my one thing would say, in addition to all of those tuning things that you read, those pale in comparison to don't be afraid to change the structure of the database to more rapidly answer the questions that you actually want to ask.
Okay.
Yeah, I would say most important thing is measure. Is make sure you understand what's being slow or what's causing it to be slow before you change anything at all. Because far too often it's easy to assume that this is the problem over there and spend ages fixing that, and actually it's something completely different. So measure, add indexes, and then buy more memory.
More memory. There you go.
Well, and I think on the search side, I mean, the notion of a right answer is not always there, right? There are probably answers that are probable, that they're likely to be the right answer and can contribute, and in some cases there are, of course there is one right answer, but just the nature of text and the ambiguity in languages often lead to the fact that there is no one right answer. But so what I always push back on to people is, and I did some of this in my talk earlier, and I usually do it in my training, is you have to take and look at what are your business needs, what goals are you trying to accomplish when people come into your search engine, what do you want, what do you care about surfacing. So relevance really does matter. Most developers and actually a lot of companies we work with, they haven't taken the time to go beyond anything other than saying, oh, well, my search is really fast, but the results are okay, or they're not sure. And so they focus all their time on the things they think they can control, which is bringing them back really fast, and they don't spend enough time focusing on, hey, how do I make sure I have really high quality results? So you can, by looking at what your business factors are, you can really often get much better results, as well as still having all of the speed, because I think the speed factor is without question in search. It's just sometimes what are the relevance performance issues.
Okay. So the question, just to repeat it, the question, if I understand it correctly, is basically, can we have components that listen, from, actually probably bidirectionally from the search engine side to the database, such that we have, better level of integration?
Yeah, and I mean, of course anything's possible, but I mean, I think one of the things that's interesting has been a trend in search over the past few years is that the search engine is becoming the authoritative store for many people. It's not always the authoritative store, and definitely other kind of data stores like databases tend to still be the authoritative store, but you're seeing more and more situations where the search engine is the primary data store. So then presumably you would start to see connectors that allow you to go to the search engine and then bring them into other kinds of things. like I know, like in, for instance, again, going back to Mahout, not to be on that, but too much, but we use, you can take from Lucene and put into Mahout. So you can do your offline analytics using Mahout while still having all your data in Lucene and Solr. So, I mean, that's one example. Whether there will ever be a, you know, a connector from Lucene that pushes into, you know, Postgres or MySQL or one of those, you know, I mean, anything's possible, and if somebody writes it, there probably would be somebody who would use it. So, you know.
So the way we're planning to wean ourselves off Oracle is to make our current concept API, which is read-only, make that writable as well. And so when you write, it will write both into our backing store, which currently will be Oracle, and into Solr. And so kind of we're fixing the problem again by putting an API in front. But that's not a very efficient way of doing it, but it's what we're doing.
Yeah, Josh.
Well, as I said earlier, I mean, I think we're going to see an increasing amount of this because people already need to do it. And I don't see any reason why it can't be bidirectional. Right now, most of the implementations that I'm seeing are, you know, asynchronous queuing implementations, which actually work for a lot of things. I think data stores in general, both on the relational and the non-relational side, need to develop better sort of public APIs for knowing when a change has happened. That would be the biggest thing to make this kind of integration easier. I know we have work to do on the Postgres side of that, and one of the things we'll grapple with in the future is that users don't always want it to be asynchronous. There are cases where they actually want a synchronous change, where they want to do effectively what amounts to two-phase commit between two different data stores. And there's a whole set of problems to grapple with there.
Okay. Please join me in a round of applause for our panelists.